Swayam Prabha. Digital India. Educated India.
Now, till now we have been analyzing the section with the rectangular cross section, right. Now, for a change, let us analyze the section with the I section, when the section is a I, and see what changes in our computations when a simply supported beam is like an I section. Okay. So, still I am looking at a simply supported beam subjected to a uniformly distributed load W, but the cross section is now I shape. Okay. Let us assume the following dimensions for this section. Let us assume the web thickness is Tw and depth of web is H. Let us assume the flanges is of width B and thickness Bf and thickness Tf. Let us assume this flange is also of thickness Tf and this flange is of width Bf, same flange thickness and flange width. Okay. Now, there are many questions that we have to answer. What is the centroid of the cross section, what is the moment of inertia of this cross section, and so on. Let us deal with each of them one by one. Okay. As usual, I am assuming this to be x, this to be y, and this to be the z axis, and hence for this will be the y axis and this to be the z axis to start with. I do not know where the centroid is. So, I am assuming that I am at the bottom flange for the z axis and I am at the center of the web for the y axis. Okay. This is just an assumption, you can assume the y and z axis to be anywhere you want to, and correspondingly you will get the centroid value for those things. Okay. Now, how do you find the centroid of the cross section? These things you should know already, hence I will go fast. Okay. To find the y centroid is integral y dA divided by integral dAx Ax. I can divide it into 3 zones, one for this zone, one for this web, and the other zone for this top flange. Okay. So, basically doing that, I write it as Bf into Tf into the centroid of this would be Tf by 2. I know that from the previous analysis for the centroid of a rectangular section. So, this into Tf by 2 is for the bottom flange, this is for bottom flange plus I have H into Tw into H by 2 plus Tf, this would be for the web plate plus Bf into Tf into H plus Tf plus Tf by 2, this is for the top plate, that is the centroid. I am multiplying the area of the centroid of the respective sections, okay, divided by the area H into Tw plus 2 times Bf into Tf, the area of the bottom flange and the top flange. Okay. So, this will tell us that now what will this give me? This will give me Bf into Tf into 2, Tf square into 2 plus H into Tw into Tf plus h square Tw by 2 plus h into Bf Tf divided by h into Tw plus 2 Bf Tf. H by 2 plus Tf, then I will get it as HTW plus 2 Bf Tf divided by HTW plus 2 times Bf Tf. Okay. So, that will be H by 2 plus Tf. Okay. Okay. So, similarly, now Z centroid would be integral Ax Z dAx by integral dAx Ax. So, that is going to be Bf into Tf into Z centroid would be Bf by 2. This is for the bottom flange. For the web it is going to be H into Tw, which is the area of the web, into I have to give the position of this web. The CG of this web is assumed as Bf by 2. Okay, this is for the web plate, plus for the top flange is going to be Bf Tf into Bf by 2 for the top plate, top flange, divided by 2 times Bf Tf plus H Tw. It is easy to see that this will be nothing but Bf by 2, which will be your Z centroid. Okay. So, from this we find that where the centroid of this cross section is, right. Okay.